My name is Patrick Robb. I am the FDM Product Manager for Stratasys Incorporated, located out of Eden Prairie, Minnesota. The FDM process itself is relatively simple. We have on the front end, we have a software application which we call Insight, which allows me to take in an STL file from a CAD tool itself. Once that file goes to the system, to the FDM machine, the filament comes to the head. The filament is fed within a canister. It is a filament form. It goes to the head. The head then turns around and has a liquefier. I melt that material and I use it as a pump to build geometries. Unlike conventional manufacturing technologies where I'm extracting material or taking material away from a part, I'm doing just the opposite. Growing a part or manufacturing a part from zero, nothing, and starting to build that part up. So it gives me much flexibility and great flexibility to, one, build things that can manufacture parts that I couldn't manufacture any other methodology, any other technologies. As I referenced earlier, I have the capability of building a hollow part, being that outside perimeter, and have a shell inside of which, if weight reduction is key, which it is for many organizations, being able to take that weight out of and still retain strength of that part to reduce the weight. My T-Class platform today consists of 6 different machines. 6 different being my Vantage. My Vantage has 5 different configurations. And based off of those configurations is essentially being able to meet the customer's needs as well as giving them the opportunity for growth. If funding is an issue in the beginning, they can start that system with one of our base materials and single material system and then grow that platform or grow that system for investment protection to add on additional materials, add on additional speeds, add on additional build envelopes. The other side, though, is on the top of my T-Class platform, I also have what's called my Titan. My Titan is really the baseline for my T-Class. The FDM Titan is a much more robust system from the aspect that it allows me to run a much higher temperature material. It allows me to run a material that's called polyphenol sulfone. We call it PPSF, the rest of the world calls it PPSU. The material itself is a V0 flammability rating. It also has a very, very excellent material properties, but it also has a working temperature, a heat deflection temperature of almost 400 degrees F or roughly 200 degrees C. It's a fantastic machine. The material itself is a PPSF is a different type of thermoplastic. It is not like an ABS or a PC, which are very much commodity materials and used on a lot of products. It is a much more robust material that requires heavy processing. Then at the very top end of my spectrum, I have my FDM Maxim. The Maxim is an ABS-only machine, ABS and ABSI. It has one of the largest build envelopes in the industry. It's a very accurate and predictable machine. We have, with our polyphenol sulfone, we have one layer thickness, one slice that we can work with, which is 10,000ths of an inch. On my polycarbonate, I can work with 10,000ths of an inch and 7,000ths of an inch layer thicknesses. My ABS, ABSI, PC ABS, those can get down to the 10,000ths, the 7,000ths, the 5,000ths of an inch layer thickness. The ABS and ABSI also recently introduced, we've got also as a 13,000ths slice. So if I want to have a little bit, sacrifice some surface finish for the aspect of speed and still having a robust, fast part and a robust, real part, I can go to a 13 slice and build a part much quicker because there are several applications and several usages of this where the surface finish doesn't have to be like a glass. Depends on what the application is as to what that surface finish requirement is. And if it's behind the skins or it's got a one-purpose job, who cares what the surface finish is as long as it does the job?
Now, I'm Frank Schaflin with Stratasys and I'm based in the Frankfurt office. I'm the technical support manager. Now, this is a concept model for a design study, especially verifying the colors, but also the function of the design itself. See how it fits, see some ergonomical aspects. Now, this is built on a Maxim, FDM Maxim.